Okay, a few more substitutions, probably. Here we've got cosine and sine and dx. We know that the derivative of cosine is negative sine, so clearly we've got some function of cosine, and then we've pretty much got its derivative here. So I am thinking, based on that, that if we make u cosine 8x, that might get us somewhere. Were you thinking of putting the fourth power on? Because if you do, let's just quickly run through that and let's see why it doesn't work so well. If you do u equals cosine to the fourth 8x, then your derivative begins with 4 cosine to the third 8x times, and then the chain rule kicks in and we get our negative signs. And there's no place to put this. If we call this part u, then our du contains more cosines than the integrand actually has in it, and we end up not being able to get a nice substitution. So this is too big of a bite to be our u. But if we use just cosine 8x, I think things will go fairly smoothly. The derivative of this will be, the derivative of cosine is negative sine 8x times, and then the derivative of 8x, which is just the number 8, and a dx pops out at the end. So if I pretty that up a little bit, du equals negative 8 sine 8x dx. So this u, we can just say u to the fourth to take care of this part. Sine 8x dx is all part of the integrand, so that part's taken care of. This negative 8 is not part of the plan, so let's divide both sides by negative 8, and we get minus 1/8 du equals sine 8x dx. Okay, so u to the fourth will take care of this part, and now sine 8x dx, this, we can replace with minus 1/8 du. We got everything lined up. So here's our new improved integral. Cosine of the fourth 8x is u to the fourth power. All this, sine 8x dx, gets replaced with minus 1/8. I really like keeping those numbers outside of my integrals, so like so. Okay, and now the power rule can take this home for us. Minus 1/8 times power of u goes up by 1, divide by the new power, or multiply by the reciprocal of the new power, and throw in a plus c, and that's pretty much it. Minus 1/40th is our new coefficient. Instead of u is cosine 8x, so we can put that in here. To the fifth power plus c. And if you want to write that as cosine to the fifth of 8x, by all means do that. That's standard notation. D looks like it's out of reach because it contains an exponential function and a logarithm, and we haven't discussed their derivatives. But I thought I'd point this out. Something kind of funny happens with this one. This is able to be simplified a lot if you remember some properties of exponentials and logarithms. So if you're rusty on that, don't worry about it. This is outside the scope of the course, but I thought I'd point this out just because it's a cute trick that they played here. We have here an exponential of base e, and the natural log is a logarithm of base e. So when they write e to the natural log 4x, what they're writing is e to the log base e of 4x. And then we have 1 over x dx. These are inverse functions. They cancel out. The value of this entire expression here is simply 4x. And then we have 1 over x dx. The x's cancel, and so this entire thing is the integral of 4 dx, which would be 4x plus c. So You may not have thought about these for a while, and that's all right. But in case you still have those in your head and wondered if you could handle this one, sometimes you can, and sometimes we give you an integrand that's a little more complicated than it needs to be. Don't think you have to dive into the integral right away and start hacking away on it exactly as written. If you see a way to simplify your integrand, then definitely do it. You can see how much it cleaned this up. It took it from very hairy looking to no big deal at all. So don't assume we're always giving you nice expressions. Sometimes there's some cleanup that can be done that'll make your life a lot easier.